The secret blob beneath New England, a journey deep inside the Earth. Hello, all. Today, we're going on a scientific detective story. Our mystery is about something huge, hot, and very, very slow that's hiding deep beneath our feet. It's a giant blob of hot rock under New England, and scientists call it the Northern Appalachian Anomaly, or NBAA for short. You might think that the ground under us is pretty quiet, especially on the East Coast. But scientists have discovered that there are amazing things happening deep in the Earth that tell a story from millions of years ago. A story that is still going on today. What is this giant blob? First, what does anomaly mean? It just means something that's unusual or different from what you'd expect. And this blob is definitely unusual. Where is it? It's located deep in the Earth's mantle, the thick layer of rock beneath the crust we live on. It's centered under states like New Hampshire and Vermont, but is so big, it stretches across most of New England. How big is it? It's enormous, about 250 miles wide. What's it like? It's a zone of rock that is much hotter and softer than the rock around it. Think of it like a giant, slow-moving bubble of heat rising through the Earth's interior. How do scientists know it's there? We can't just dig a hole 125 miles deep to see it. So how do we know it exists? Scientists use a clever technique called seismic tomography. Imagine the Earth is like a giant bell. When an earthquake happens, it sends vibrations, called seismic waves, ringing through the planet. Scientists have thousands of sensors all over the country that listen to these waves. It's kind of like a doctor giving the Earth a CT scan or an ultrasound. By measuring how fast these waves travel, scientists can create a 3D map of what's inside the Earth. They discovered that when seismic waves pass through the blob under New England, they slow down. Waves travel slower through hotter, softer rock. So that's how we know the anomaly is there and that it's hot. Where did the blob come from? The origin story. For a long time, this blob was a huge puzzle. The east coast of the US hasn't had major volcanoes or tectonic action for nearly 200 million years. So why was there a big hotspot there? The old idea. The first guess was that it was leftover heat from when the supercontinent Pangaea broke apart, and North America split from Africa about 180 million years ago. But scientists realized that was too long ago. A hot blob like this would have cooled down by now, just like a cup of hot chocolate eventually gets cold. The new theory. A tale of two continents. A new and exciting theory connects the blob to a more recent event. The splitting of North America and Greenland about 80 million years ago, which created the Labrador Sea. Here's how it works. Imagine a lava lamp. When the continents began to stretch and pull apart, it created an instability deep in the Earth. A cold, heavy piece of the tectonic plate dripped down into the hotter, softer mantle below. You can picture it like a drop of cold molasses sinking into warm honey. As that cold, heavy drip sank, it pushed the hot, lighter rock of the mantle up to take its place. That rising column of hot rock is the blob we see today, but it gets even cooler. This didn't just happen once. The first drip triggered a chain reaction, like a line of falling dominoes, creating a series of drips that moved slowly inland. Scientists call this a mantle wave. The Northern Appalachian Anomaly is just one of the drips in this ancient chain reaction. A blob on the move. This means the blob didn't actually form under New England. It was born about 80 million years ago, far to the northeast, near where Greenland was splitting off from Canada. Ever since then, it has been slowly migrating southwest. And when we say slowly, we mean really slowly, about 12 miles every million years. To give you an idea, that's much slower than how fast your fingernails grow. Based on its speed and direction, scientists predict it's currently heading toward New York City and will arrive underneath it in about 10 to 15 million years. So, no need to worry, but it's a great example of how the Earth is always changing. Why does this blob matter? So, who cares about a slow-moving blob of hot rock deep underground? It actually has some amazing effects on the world we see today. It keeps the mountains high. The Appalachian Mountains are ancient. After hundreds of millions of years of erosion from rain and wind, they should be much flatter than they are. The heat from the anomaly acts like the flame under a hot air balloon. It makes the continent lighter and more buoyant, pushing it up from below. This uplift helps the Appalachians stay tall and majestic. It has a twin. If a drip formed on the North American side of the split, it makes sense that one would form on the other side too. And guess what? Scientists found a twin anomaly under Greenland. This twin is now affecting the massive Greenland ice sheet, adding heat to its base and influencing how it melts and flows. This is a direct link between an 80-million-year-old geologic event and our modern climate system. It's part of a bigger family. Remember the mantle wave and the falling dominoes? Scientists think another anomaly to the south, called the Central Appalachian Anomaly, is an even older drip from the same chain reaction. This shows that these aren't just isolated blobs, but part of a huge connected system that is still shaping our continent. In conclusion, our planet is alive. The story of the Northern Appalachian Anomaly shows us that even in places that seem geologically quiet, the Earth is incredibly dynamic. The echoes of continents breaking apart millions of years ago are still shaping our mountains and even influencing our climate today. It's a great reminder that our planet is always in motion, with incredible secrets waiting to be discovered right beneath our feet.